All right, here we go. We're talking about deuterium depletion, the new standard for human performance. We're going to bring up Mr. Victor Sagalovsky, co-founder and CEO of Litewater Scientific. He is holding his bottle. You can get a visual on what this looks like. Beautiful. The first and only super deuterium-depleted light water, where he has dedicated himself to the research, development, and production of this rare water. Woo! Victor.
All right, take it away.
Do you want to give your... Oh, yeah.
Thank you. So what I'm going to talk about is the most profound, the most impactful biological discovery of our times. And very few people have heard about it. And it is deuterium depletion. And you get to the state of deuterium depletion by drinking deuterium-depleted water. This is a very interesting concept because unlike all other health interventions that put something in your body, this is about taking something out. And what we're taking out is deuterium. Has anybody heard the word deuterium before? Got it. We got one, we got two, we got a few. But everybody's heard of hydrogen, right? Everybody knows what hydrogen is? Right. So deuterium is a heavier form of hydrogen. This discovery has to do with a lot of technology. So to reduce deuterium from your water is not a simple process. It's not something you can do in the home. It's something that requires big industrial scale production facility like this one that we have. And it's really a mitochondrial intervention. So these lovely organelles that have arrived on this planet 1.45 billion years ago and intertwined themselves into the human operating system provide us the energy that we use to respirate, to ambulate, to procreate. If it wasn't for the mitochondria, we wouldn't be here. And that's why we all have two sets of DNA. Two sets of DNA. You have your nuclear DNA and your mitochondrial DNA. So what we have is a synthesis of two organisms in the cell that cooperate symbiotically to keep us alive. So this is what we make. We make deuterium-depleted water, and this is the purest water in the world. And what makes it the purest water in the world is because it's pure H2O. Well, we look at water, we think water is pure H2O, but it's not. But let's start with a little science lesson first. We've all seen the periodic table of elements, and hydrogen is the first element in the periodic table. It's the simplest element in the universe. It still makes up 70% of the universe. It's the first element created in the universe. And it's what runs our biology. We run on hydrogen. In fact, not only we run on hydrogen, stars run on hydrogen, and just about everything is powered by a version of hydrogen. So in hydrogen, you have a little issue going on, and that is that there's more than one type of hydrogen. You have the protium hydrogen, which is the most abundant form, and then you have deuterium. And the difference is deuterium is hydrogen, but it has an extra neutron. So it makes it twice the mass. Okay? 99.98% of all the hydrogen in the universe is the protium version of hydrogen, and that's the hydrogen that runs our biology. And then 0.0156% is deuterium hydrogen. Now, where did this deuterium hydrogen come from? Well, before we get into that, let's talk a little bit about water. We live on a water planet, but when we analyze it, we find out that 3% of the water is fresh water. So for our biology, 3% fresh water is all we get to keep our life going, right? Now, out of that, most of it is locked up in glaciers, 75, 80%. So really, 1% of the water on this water planet is usable for plants and animals. And there's an uneven distribution of deuterium content in water. So 155 parts per million is what you find in the ocean. And then it goes all the way down to 89 parts per million in the Antarctic. Just keep this in mind as we go forward. So, if you have a liter of water, you could look at that as 20,000 individual drops, right? Like a dropper. And out of these 20,000, 6 of these drops is not in the configuration of H2O. It's HDO or HOD. That second hydrogen being replaced by a deuterium, which has that extra proton, which makes it twice the mass. Now, you'd think this is no big deal, but I'm going to explain to you what a big deal this really is. So, it's just a simple illustration of the difference that happens when you have an extra neutron. This extra neutron makes hydrogen heavier, twice the mass. So when it combines with water, it changes the structure of that water. It makes it heavier, and that's known as heavy water or semi-heavy water. And these are the 6 drops in every liter of water that we drink. So oxygen doesn't discriminate, so it also binds with deuterium as it binds with hydrogen, and this is why we have these different waters. The normal water, which is the water that runs our biology, the imposter, the HDO, and then pure heavy water, which is synthesized in a lab or concentrated in a lab. It doesn't occur, when it occurs, 1 out of every 41 million molecules of water is pure heavy water. But the one we really have to worry about is that one. Because 1 out of 3,300 water molecules, like I said, that's 6 drops in 10,000, is in this HDO configuration. And this wreaks havoc on our biology and causes us to age prematurely. So the good news is when you remove it, you extend your youthfulness all the way into old age. So many of us learned in high school, at least I did, that we're 75% water. But in fact, that's not altogether true. If you look at it by molecular mass, we are 98.73% water. So just about every molecule in our body is interacting with water in some shape or form. We are a body of water. We have an inner ocean. So where does this come from? Where does this deuterium arrive? How did it get here? Well, it got here from the very beginning of creation. Simply, in the beginning of creation, as the Big Bang cooled rapidly, it got stuck in between the first element and the second element. So it's stuck in between helium and hydrogen. So it doesn't really know what it is, but it is a real problem. So just a simple illustration of the difference of the 3 different types of water configurations. And when you look at the isotopes of oxygen as well, in fact, we have 63 different water molecule configurations. I'm giving you a little bit of science because this leads somewhere, and understanding this is really all about educating yourself on how water works in the body. So we're going to have some quick facts to consider, and some really profound facts, right? So the water that we make in our bodies, all the way inside the mitochondria, is not the water that we drink. None of that water gets in there. In fact, the water that our bodies make inside the mitochondria that we synthesize is deuterium-depleted. So if you drink deuterium-depleted water, you're actually putting in the water that is similar to the water that your body makes. This is called metabolic water. And your body, our bodies, every mammal, recycles about 1,500 gallons of water per day. Just think of it. You have 1,500 gallons of water being recycled in your body in a 24-hour period. That's just profound. And so we lose water, so we have to replace it. We recycle about 20% of the water that we drink or the water that we have in our bodies. And the rest we have to replace because we lose it, mostly through breathing. So because of this deuterium problem, we're burdened by about 1 to 3 grams of deuterium in our bodies. And I'm going to show you how this wreaks havoc on our biology. But first, I want to share with you when this was discovered. because this discovery is less than 100 years old. So we are really at a very unique time in history where we're making a lot of breakthroughs and connections for our benefit, for radical life extension, and for radical health extension. So this was discovered in 1931. They discovered that there were different isotopes of hydrogen. And soon after, they started thinking, well, do these have any biological difference? And so it was all the way back to 1933, they surmised that if heavy water has a lethal action that is to be expected, that feeding a seed on water containing only protium will result in a more rapid development. And this is the big breakthrough. What happens when humans drink deuterium-depleted water consistently over time and lower the deuterium burden inside their bodies? 1933 was a very different time than it is today, and in fact, Dr. Urey, who discovered deuterium, different isotopes of hydrogen, there are different forms of the most abundant element in the universe, won a Nobel Prize for this. And shortly thereafter, they started doing all kinds of experiments with heavy water to see what kind of biological benefit or detriment or what possibly happens when you consume heavy water versus regular water. And they discovered some very interesting things. Basically, if you drank pure deuterium water, pure D2O, which is very bad for us, you pretty much die within a few days because it's not biologically compatible. And I'm going to go into the science of why it's not biologically compatible. So the Russians started looking into this in the 50s as well. So the Americans discovered there's this deuterium isotope of hydrogen in the 30s, and they started working with deuterium in nuclear reactions. So you need deuterium to create atomic energy. That's a different subject. And the Russians started looking at it the other way. They started looking at, well, what happens if you reduce the amount of deuterium in water? So in the University of Tomsk in Siberia in the 50s, there was a young biophysicist and a young gerontologist, and they went to their senior professor and said, we want to make a name for ourselves. What do we do? What do we need to work on? And he said, find out why these people that are living over 100 in Siberia, they have no electricity, they have no roads, they have no medical doctors, they're basically living like Eskimos. Find out why there's 6 times more centenarians, people that live over 100 there than anywhere else. And if you discover that, then you'll make a name for yourself. And sure enough, they pursued this. And this is very interesting. You've got, if you take a census, this is a census done in the 1800s. You see there's 1,789 centenarians, and a few of them said they had reached the age of 160 years, which is quite phenomenal. And even 195, some oldest woman. And what are they doing differently? So they wanted to find out. And these are the people that they were studying. And what they discovered was it doesn't matter what your environment is like or where you live. What mattered is how much deuterium you had in your body. So they started researching these people. And at first they didn't know what it was that allowed them to live so long and so full of health and so vibrant and so disease-free. And then they started looking at everything. Started looking at the food they eat, their spiritual practice, and then they looked at the water they drank, and they said, aha, the water they're drinking has 20% less deuterium than everywhere else. And this has to do with the distribution of deuterium in the water around the planet that I showed you earlier. So some places have less, some places have more. And if you ask me, I'll explain that later, but we don't have enough time for that. So, okay, these people in Siberia were drinking glacial water. It had less deuterium. They discovered this, and then they published in 1961 for the very first time that if you lower the deuterium in your body, you will increase your metabolic output and decrease your aging process. And then the Americans published this a few years later, Biological Effects of Deuterium, where they show you exactly what's going on in your physiology and with these isotopes of hydrogen and how they work. So if you increase the amount of deuterium in your body, it leads to all kinds of damage, including cancer and metabolic decay and an increase, a quicker aging process. So that's what I was saying. If you were to concentrate pure heavy water in a laboratory, even a 35% concentration of heavy water, you will die on the 5th day. But it looks like water and it tastes like water. In fact, it is water. It's just heavy water because the hydrogen is the heavier form of hydrogen. So jump cut to 2007, Dr. Olgun, who I'm standing with here, discovered the exact mechanism by which deuterium damages our mitochondria. And that has to do with ATP synthase. Has anybody ever heard of the word ATP synthase? Great. So inside our mitochondria, of which we have trillions, 100,000 trillion mitochondria in our body, 45 trillion cells in our body, and each mitochondria has 320,000, give or take, of these ATP synthase nanomotors. And these nanomotors spin at 9,000 RPM. They're like little molecular machines. And they create the they create ATP, which is the energy currency of our biology. And they're working all the time. And by the way, they can do something that no machine that we've created can do, which is spin at 9,000 RPM and have perfect 100% efficiency. It looks like a motor. It works like a motor. It is a nanomotor. And these are the motors that produce the energy in our body. And what Dr. Olgun discovered, knowing how these motors work, he discovered how deuterium damages them. And it's very simple, actually. It's a mechanical process. And protons, simple protons, spin this motor and produce ATP. They go from one side of the membrane and the other, and there's a gradient here, and these protons want to get through to the other side. And you have this dance, this beautiful dance of pH and voltage that happens to allow these protons to flow, spin this motor, and create ATP. But every time that you have a deuteron, which has that extra neutron attached to it, every time that goes through these motors, it causes them to stutter. And that creates big problems over time because this is a consistent stuttering that happens stochastically every 8 to 15 seconds or so. So constantly, from the time we're born to the time we die, we are compromised by this deuterium as our bodies try to produce energy in the innermost membrane space of our bodies, which is the ATP synthase. So every time that happens, a stutter effect induces no ATP production. The stutter also induces reverse electron transport that creates reactive oxygen species and eventually shuts down that mitochondria. You have apoptosis, and then as we age, we have less mitochondria than we are young. If you take a simple muscle cell, when you're a teenager, that muscle cell may have 50,000 mitochondria, and then when you're older, it may have 500, 200, much less. So the factories start shutting down in our bodies because of this deuterium. And it's a natural environmental toxin. So why did Dr. Olgun, who's a doctor, a dean of a medical university, incredible research scientist, why did he even start to look at this problem? Well, because he looked at the blood and he said, there's a lot of deuterium floating in here. Before this, it was believed that, yes, we know deuterium is a problem, but there's so little of it, can't be that big of a problem. But sure enough, when you look at the blood plasma, you see the concentration of deuterium is 5 to 10 times more than the basic constituents that we need for life, such as magnesium, potassium, glucose, calcium. So you've got a lot more deuterium than you realize, even though there's so little of it. But it concentrates over time in our bodies and wreaks havoc on our biology. So remember when I said earlier, 1,500 gallons of water was recycled in our bodies daily? This is all through reactions. And you could look at how many reactions require water in our bodies, and it's in the thousands. You do one search, you get 4,000 reactions require water. You do another search, you get 2,000. It's quite profound. Everything in our bodies has to do with water, with our inner ocean. So the 6 drops of heavy water in every liter of water doesn't seem like a lot, but in fact, it's huge. So it's a simple illustration of what happens with deuterium interference and without deuterium interference. You have this stutter and this shaking. And I liken it to, the analogy I like to give is that every morning you wake up and you get a kiss from your partner. And this goes on for many days or months or years. And once in a while you wake up in the morning, you get an elbow to the face and a kick to the groin. And then the next day you go back to a kiss. And this happens over and over and over until the mitochondrial membranes weaken, you have proton leakage, and then signal is sent out to shut it down. And you lose that mitochondrial, you lose that energy production center that is so important for our youthful vitality. So, maybe somebody can complete this rhyme for me. Roses are red, I wish you well. Anybody? Mitochondria is the powerhouse of the cell. But to call it the powerhouse of the cell is almost like saying a nuclear reactor is a space heater. These organelles work nonstop to produce energy in our bodies. And so there's this cycle called the Krebs cycle. Before you get into something called the electron transport chain, at the end of the electron transport chain are the ATP synthase motors that create the ATP, or synthesize the ATP, recycle from ADP to ATP, which is the energy currency of our biology, as I've mentioned before. And before that, there's something called the Krebs cycle. And this is a cycle that's very complicated. And if you're a biochemist, you look at this and go, why is it so complicated? Everything in nature likes to take the path of least resistance, except this cycle. And it turns out it's a series of gates that try to limit the deuterium from those energy production centers in the electron transport chain. So for anybody that understands biochemistry, you just learned what the TCA cycle is all about. But unfortunately, you can't block all the deuterium. So deuterium still gets in. And like I said, every 8 to 15 seconds, our motors, our 320,000 motors inside 100,000 trillion mitochondria stutter and are stressed and impinged upon and burdened by this heavy hydrogen. Here's an illustration of how they're lined up. You have these beautiful motors, and they spin constantly and produce our ATP energy. Simple illustration of how it works. So, these small nanomachines in nature, like I mentioned, are very much like a motor. And back as far as in 1990, even before Dr. Olgun in 2007 discovered the mechanical process, how ATP synthase is damaged, they were already starting to make some connections and having some aha moments and realizing that deuterons cannot replace protons in active transport processes in yeast. So they already were starting to figure out 35 years ago that deuterium is incompatible with biology. And in fact, all the way to in the 60s, they were saying this. This is incompatible with biology. Even though it's a form of hydrogen, it just doesn't fit where the protium hydrogen needs to go to produce energy. It's too big. It's cumbersome. So Dr. Olgun discovered this, and he gave the exact mechanism of how it works and how it causes our ATP synthase to stutter, but if you don't understand this graph, all you need to understand is that it grinds our gears. Displacement of protons by deuterons grinds our gears. It's like getting sand in your motor. It's just a small amount of sand, right? What possible damage could it do? But over time, the damage is severe, and it causes aging. So just some simple illustrations of what these ATP synthase nanomotors look like and how it works. They, like I said, they only have a spot for a proton. That's just what evolution dealt us. So every time you have a deuteron come in, it doesn't fit in that motor. It's a square peg in a round hole. It's an elephant in a china shop. And it happens nonstop. Some more illustrations of these incredible nanomachines. It's actually a really good argument for intelligent design, because there's really no possible way nature could have put this together so elegantly without intelligent design. And it looks like a motor. And it functions like a motor. So when you compromise ATP synthase, you get a lot of different diseases. Renal diseases, skin diseases, acidosis. I mean, you got lots of named diseases, Alzheimer's, Parkinson's, you name it. If you compromise these ATP synthase motors, they lead to very bad things. So we want to keep the ATP synthase healthy. We want to keep the mitochondria healthy. And the way to do that is to reduce the deuterium burden. And what happens is when you have something that's stressed, like an ATP synthase motor that's stuttering, it causes a shaking. That shaking causes a reverse electron flow, which creates reactive oxygen species. And then we have to produce more antioxidants to fight these reactive oxygen species. And it's a losing proposition over time, unfortunately. So here's an example of somebody that's deuterium depleted, that has 40% less deuterium than everybody else. This is a test, a me-screen mitochondrial assessment, specifically looking at reactive oxygen species. And in fact, this person is me. And so you see here, very low, incredibly low amount of ROS. The reason I have very low ROS is because my body is deuterium depleted. So I have very low metabolic stress. I removed the vector of stress, real vector of stress, which is deuterium. And so it doesn't matter how stressful my life is. It's pretty stressful. It doesn't show it in the mitochondria. The mitochondria, it shows beyond optimal reactive oxygen species. So, just some quick facts for you. Each ATP synthase enzymes contains 10 C subunits. Proton passage rate from the top of the motor to the bottom is about 1,000 protons per second. This is happening so fast. When you zoom into our biology, everything happens at this quantum level, like almost instant. And then every few seconds, like I mentioned, these ATP synthase get impinged upon by deuterium, and this causes damage. And this is damage from the most inner confined spaces within our bodies. As far upstream as you can go, this is where the damage is done. So if we cut off that damage at the source, then everything downstream of that will benefit. All right. So it's a bad neutron. That's what this is all about. And it's about minimizing that bad neutron and reducing the amount of deuterium in our bodies. So this is just an illustration showing you what happens. You start off with good mitochondria, all of a sudden your mitochondria age, and why? Why does that happen? Well, the harbinger is deuterium. Not so fun fact, it's the water that we drink is what ages us, because all water has deuterium. Like I mentioned, the ocean is 155, and most water that we drink is 150 ppm, and in certain places, it's lower. And in those places, this is where those populations were studied that had such extreme longevity and health span and lifespan, because their water was 20% or more reduced in deuterium. It's very simple. That's the good news. We figured it out. Deuterium is incompatible also with quantum mechanics. We're going to dive in a little deeper, even deeper than the mitochondria right now, and make some further connections of how deuterium damages us. So, has anybody ever heard the term quantum tunneling? Okay. So, quantum tunneling is a very interesting phenomenon because it shows that in order for us to live and breathe, we have to break the laws of classical physics to exist. The laws of physics as we know it do not apply to us. We have to break them. And if we didn't break them, we wouldn't be here. And that has to do with quantum tunneling. So what quantum tunneling is when you have one particle and it gets to the other side of, it goes over a barrier. Okay, let's say imaginary barrier like a mountain. Okay, normally we know that if we want to get to the other side of a mountain, we have to climb that mountain, and then we have to climb up, and then we have to climb back down to get over it. In quantum tunneling, you start on one side of the mountain, and then you blink your eyes like Genie, and you show up on the other side instantly. It's like teleportation. And we don't know how it works. But hydrogen does this. It says, I've got so much stuff to do, I can't be bothered with climbing that mountain. I will just teleport myself from here to there. And everything in our biology works like this. And it's not compatible with classical physics, but this is quantum physics. So quantum essentially is just being in two places at once. And this is done without any energy output. Like, you know how hard it is to climb a mountain, but this happens without any energy. You just start in one place, all of a sudden teleport yourself to another. And this is how our biology actually works. Hydrogen quantum tunnels. Hydrogen is the only element that quantum tunnels, and that's why we use it for energy. Now, deuterium, being a version of hydrogen, a heavier form of hydrogen, an imposter form of hydrogen, also quantum tunnels, and this creates a problem. This creates a problem because it quantum tunnels slower. And so that's known as the kinetic isotope effect. How quickly does hydrogen disassociate from another molecule? So a good example is a carbon-hydrogen bond. So most of the bonds in the body are carbon-hydrogen bonds. We are carbon-based life forms after all. So if you have a carbon-hydrogen bond disassociating versus a carbon-deuterium bond disassociating, the disassociation rate of the deuterium is 9 times slower. And this creates an incredible problem for biology because we like the path of least resistance. We like everything to be in coherence. And this is the opposite of coherence. This is disorder. This is chaos. So the deuteron causes a problem. The reason it disassociates 9 times slower is because that bond is a stronger bond. It's a shorter bond, so that makes it stronger. So they're very different, the protium version of hydrogen and the deuterium version of hydrogen. And this is like a wolf in sheep's clothing. It looks like hydrogen, it acts like hydrogen, but it's a very bad form of hydrogen. I tend to liken this to an athlete that's about to run a marathon or a race, and they're well prepared for it. They've trained, they've done everything they needed to put themselves in the best shape to run this race. And then, right out of the gate, they step in a wad of gum. That's what this is. It's gunk. It just creates an undue burden for us. So we want to remove it. We want to remove it out of these elegant nano machines that we call mitochondria. And by the way, we don't know where they came from. They just showed up and said, hey, we want to get into a contract with the early eukaryotic cell. They said, we'll make the water, we'll provide the energy, you give us the protection, you give us the food, and that's a marriage that's lasted 1.45 billion years. And that's why we have two types of DNA, because really, this is a proto-bacteria that somehow intertwined itself into the human operating system. We're all biological operating systems. All organisms that use oxygen. So in fact, deuterium is the Trojan horse, because our body mistakes it for hydrogen. Our body mistakes heavy water for water. And then when this mistake is made, if we know the story of the Trojans, we know that it gets inside the gates and wreaks havoc on our biology. And there's a book written by a researcher, scientist in this space, Dr. Gabor Shamlai. It's very good because it talks about over 3,000 clinical studies over the last 30 years that he's performed. And he shows actually through people and their experiences with cancer and other diseases that the survivability rate when you reduce your deuterium is about 9 to 10 times more than without it if you have a serious illness like cancer. So, how else does deuterium damage our bodies? We've talked about the ATP synthase, the mitochondria, we've talked about the kinetic isotope effect and quantum tunneling, and now we get to DNA. Well, DNA is pretty much made up of hydrogen, right? All these guanine, adenine, thymine, right? They all have a lot of hydrogen in them. So DNA needs to be in a certain configuration, a certain shape. If it doesn't hold that shape, it doesn't replicate properly, and then mutations happen. So in the human genome, there are 3 billion base pairs of DNA. That means 10 million deuterium atoms in our genome. So there's one deuterium atom per 300 base pairs. Now, what if this goes up? What if you have a little more deuterium? It starts to distort the shape of our DNA simply because it's heavier. A deuteron takes the place of a proteum, and it distends the shape of the DNA, and then it can't replicate properly, and this leads to mutation. This is as far upstream as you can go, DNA. And so if you got something that damages your DNA, it's something that we should know about. So, simple graph, number of deaths from cancer per 100,000 people of a specified age. Accumulation of DNA errors goes up, chance of risk of getting cancer goes up. It's very simple. You have mutations that happen. We're basically a Xerox copy of a copy of a copy of a copy. And the more coherent our replication, the more we stay youthful. And the more deuterium and more DNA problems occur, the more mutations occur, the more we have the outward physical signs of aging, and of course the internal signs of aging as well, which is sluggish metabolism and everything downstream of that. So, at low levels of deuterium can slow down replication processes or otherwise interfere with repair of DNA damage by solar radiation. This is something published 26 years ago. In fact, if we want to have less damage into our DNA, we lower the amount of deuterium in our body. It's a simple equation. Less DNA contamination of deuterium, better replication of DNA, better coherence. So DNA is a double helix, and then we also have a triple helix, and that triple helix is collagen fibers. And in nature loves symmetry. Nature loves order. And so when you disturb that, you manifest the signs of aging. And one sign of aging is your skin, right? So we start out in life with the skin of like 5,000 thread Egyptian cotton, and then we end up with skin that looks like a potato sack as we age. And it's because of these cross-linking of collagen, and the problem being deuterium. Now, in this triple helix and all other enzymes in the body, there's something called chirality. And what it is these molecules in our body, they need to be, in order for them to function the way they're supposed to, they need to be a perfect mirror image of each other. So you have a molecule, and then on each side, you have these atoms configured into molecules, and they are like a mirror image of one another, right? It's like if you're on a plane, your two wings have to be completely identical in shape, size, and mass. So if you have one wing that looks like the other wing, but it's a little heavier, that plane's not going to fly, and if it does, it's going to crash. So what happens in these molecules, if you've got, on one side, you've got a hydrogen, and on the other side, you've got a deuterium, it's not going to have perfect symmetry. And this is a problem for these double helix and triple helix systems in our body, like collagen. This is what causes these fibers to break down, and thus you have the outward physical signs of aging. You want to reduce that, you reduce the deuterium burden. The good news is studies show that when you're, and this is a study done topically, so 150 ppm is Miami tap water, okay? And when you go down to 50 ppm, you see how much thicker the collagen layer becomes. So it works. And at the beginning of the presentation, I asked you how many have heard the word deuterium, and there were very few that said they heard of it. But in fact, there are more than 100 legitimate studies on this over the last 60 years of research. And in fact, if you go to Wikipedia, we are censored there. They don't let you know on Wikipedia about this incredible biological discovery, what I like to call the greatest biological discovery of our times. And the reason, I believe, that we are censored, that this discovery is censored on Wikipedia, is the implications for oncology. Because I told you earlier about Dr. Shimlai, who actually has a competing water brand, but I promote everybody in this space. He discovered that oncogenes, you know what oncogenes are? Oncogenes are genetic markers that give you a predisposition for cancer. So some of us have basically genetic predisposition for certain cancers, and some of us don't. But he found that when you decrease the ratio of hydrogen to deuterium, those oncogenes turn off, and you don't have that that genetic susceptibility to cancer anymore. And that's why I believe that it's censored on Wikipedia, because they don't want people to know there's a simple and easy solution. So if you want to test it out for yourself, we've created this Depletion AI. You can go to depletion.ai. Depletion is the compound word, deuterium plus depletion, and you can ask your question as it relates to deuterium, a deuterium depletion, and you'll get your answer. And it sources from over 100 legitimate studies on this subject matter. That's depletion.ai. So this is 6 decades of research informs us that deuterium is a problem. And over those 6 decades, many have realized this is a major problem, but few decide to do anything about it, because to do something about it means you have to create deuterium-depleted water, which is a very difficult process. So in the beginning, because of this deuterium problem, and I make this analogy, we start out like a 2,000 horsepower jet-fueled race car, and we end up proverbially dragged across the line by one bovine carrying the shell of what we once were, dragging our carcass to the finish line. And we can avoid this. So, there's a study, and there's more than one study, but I just wanted to just tell you that if you live in Miami, your deuterium level is about 150 ppm. And based on some really good studies like this one, it shows you that the ideal deuterium level in our body is somewhere in the 120 ppm range. But we don't have enough time to get into why, but the planet essentially has about 20% more deuterium than it used to. It's cyclical. So we want to, for optimized biology, we want to get to at least 120 ppm deuterium range. And we can do this not only through drinking deuterium-depleted water, we can do this through ketogenic diet, we could do it through fasting, but it's just a lot harder that way. So remember this map that I showed you earlier. Now, this map has a very interesting anomaly right here. This anomaly is the Himalayan mountains. Himalayan mountains, something happened a few million years ago, and in its water, there's a meteor that hit that had less deuterium in it, had water that had less deuterium, and this water got into the hydrological cycle of the Himalayas, so the water there is much lower in deuterium than surrounding areas. And so people that try to climb Mount Everest, Westerners, they have to do it with oxygen. And yet somehow the Sherpas that live there, they climb Mount Everest without oxygen while carrying everybody else's belongings. And how are they able to do this? They're able to do this because they have less deuterium. Because deuterium is an oxygen intervention as well. When your body is reduced in deuterium by 25%, you need half the amount of oxygen to do the same amount of work. This is profound, if you know what it means and the implications of it. So deuterium increases your ability to use oxygen. It optimizes it, and that's why the Sherpas can exist in that environment without supplemental oxygen. They drink deuterium-depleted water. Also an interesting, when I got into this, I looked at all the research that existed on DDW, deuterium-depleted water, and deuterium depletion. I found this guy in the early 90s wrote a book where he claims to talk with extraterrestrials, and he asked them, why are our lifespans so short? And they said to him that aging on Earth is really a disease brought on by the fact that the water on Earth contains a toxic substance called deuterium. I find this fascinating because it would be really hard for this person to know this otherwise back in the early 90s. There was just not much talk about this back then. So even the aliens tell us we have too much deuterium on our planet, and there's certainly some historical evidence as well. You can look at the Bible, Genesis 1:6-8. It says, and we separated the two waters. What are those two waters? Very good question. You have the patriarchs. After the flood, they lived to 100 and some years. Before the flood, they lived to 600, 700, 800, 900 years old, if you literally believe it. And if there's also the case of animals, too. You have the pre-flood beaver, and you have the post-flood beaver. Look at how much smaller the beaver got after the flood, whatever the flood was. That's a different discussion. So when you have less deuterium, plants and animals grow bigger, their lifespan is increased, and generally have a better time in this place when you have more energy, right? The lightness of being is what we're after. And this is what deuterium depletion gives us. It also is going to be very vital if we ever decide or have the ability to leave this planet and settle other worlds like Mars. Mars has 5 to 7 times more deuterium than Earth. And if this problem is not dealt with ahead of time, people are going to show up there and they're going to start metabolically aging and dying very quickly. So I wrote an article called Deuterium, the Elephant in the Space Capsule. You could look it up. It makes a very good case for talking about this problem now beyond anything else, because that is going to be the main problem when we try to settle other worlds. And so you just heard the good news, right? Now the bad news. The bad news is there's no conventional purification technology that can remove deuterium. It's a very difficult process that requires an enormous amount of energy. We do it by mimicking the hydrological cycle of the Earth and just amplifying it. So we've been doing this for almost 16, 17 years, and then we launched, meaning creating a factory to be able to do this. There's only 3 or 4 companies in the world that know how to do this. We're the best because we take the most deuterium out of water. 97% of deuterium in water is reduced. Like the 5 ppm is 5 ppm versus 150 ppm. That's 97% less deuterium. And basically, this is how we make them: vacuum-assisted rectification distillation. It's very, like I said, it's a very laborious process, and very little water is produced. So we're reached our capacity in terms of what we make and what we sell. So, and we're trying to expand, build a factory here in the United States. Right now, our factory is overseas. So, how does it work when you start drinking deuterium-depleted water? Well, it doesn't work overnight because you can only reduce deuterium by a small amount every day, half a ppm to 1 ppm. But if you do it consistently over time, in 90 days, you can go down from 150 ppm down to the 120 ppm range. If you stop drinking DDW, your deuterium level will go back up, but the physiological benefit will not go away. So this is where we're at. We're in a new understanding of deuterium depletion, DDW, and the significance for human biology and our health span and lifespan. I mentioned that you could also get deuterium depleted through a ketogenic diet, fasting. Certainly ketogenic diet is better than all other diets because you produce more ATP. One ketone body creates 104 ATP versus regular glucose metabolism, you get 34. And if you're ill, meaning you're creating energy without oxygen, you create very little energy. So when you fast, because fat in our bodies is deuterium depleted, slightly deuterium depleted, when you fast, you burn fat for fuel. So from 1 kilogram of fat burned, you get 1 liter of deuterium depleted water. So in the extracellular, that extracellular water burned from fat is about 115 to 120 ppm, and the water inside our mitochondria, the metabolic water, is about 40 to 60 ppm. People sometimes say, Vic, you're always out there selling me your water. And I go, no, I'm not selling you our water. I'm selling you your water, if you know what that means. So we also have a testing lab because it's good to know if this is working for you. So we test your deuterium through saliva. You can do it before, you can do it after, because the only claim that we make is that by drinking deuterium-depleted water, you will reduce the deuterium in your body. Every other biological benefit is not from the water. It's from your body being deuterium-depleted. So that's it. You got to keep your motors running to create coherence, to create optimal voltage in your body, and proper replication and repair. So that when you start drinking light water at the right time, you can avoid getting there. You can be youthful your entire lifespan. Thank you.